to introduce Tino, who will introduce to us the OpenNebula cloud platform for data center virtualization, and yes, we'll answer questions at the end of the presentation. Tino.
Thank you. Well, welcome everyone. Thanks for coming to the OSDC and to this talk in particular. I'm going to talk about OpenNebula, and I want to give also some introductory demo to the software. If you have any questions at any time, please don't hesitate to ask. I just don't want to bore you to death, so if you think that the conference is going to some place that is just not interesting, just let me know and we'll change it, no problem. Okay, so these are the tentative contents of the talk today. I'm going to do a brief introduction on the OpenNebula project, and then I'll start to describe the OpenNebula software. I will give a demo using Sandstone, which is the web interface to OpenNebula. And then we'll talk a bit about the key features and the architecture. And then I'll finalize with some information on who is using OpenNebula and what can you do to try it out. Okay, so the OpenNebula project started in 2005, or sometime before that, in a research group in a university in Madrid, Spain. It started as a research project, and in 2008, we delivered the first technology preview with the aim of develop and innovate in the field of cloud computing. From that, we have various versions of the software until the upcoming 4.0, that it's going to be in the stable release in probably a couple of weeks. Somewhere around 2010, a company, a spin-off of the research group called C12G Labs, started to give professional services around OpenNebula. So in case anyone is interested in doing a professional deployment in any company, I want you to know that there's a company that can give you support and also consultancy for OpenNebula clouds. Okay, so this is some data on the project and the software as well. So you can see the nice graphics saying that, well, the community is healthy, and the interest in the OpenNebula is just growing and starting to grow fast. So for instance, you can see that there's over 1,000 registered users in the mailing list. There's a great deal of visits to the web page, and also a lot of downloads. And we just count the downloads from our web page, and we don't count the, because we cannot, the downloads from the Linux distributions that have OpenNebula packages like CentOS, Ubuntu, Debian, and SUSE. So what is OpenNebula? OpenNebula is basically a cloud management platform. So it builds a virtualization layer on top of your physical infrastructure, and it helps to build you private clouds, virtualizing the resources you have in your data center. So it basically helps you manage the physical servers, the networking layer, and also the storage service. So it's an orchestrator of mainly three of those three resources: storage, networking, and computing power in the form of hypervisors. It also has components to help you build hybrid clouds, so you can extend the power of your local infrastructure with public cloud providers like Amazon EC2. And it also helps you to build public clouds for external consume if you are interested, using public cloud APIs, like, for instance, Amazon EC2, or also OCCI, which is the OGF recommendation for cloud computing interface. And at the end of the day, what it does, it enables service virtualization. So it helps you virtualize your servers and manage them, It also helps you manage the elasticity of the services, and basically allows you to have multi-tenancy in your physical infrastructure to give services to different groups or people, in a way abstracting the details of your infrastructure and just giving computing power to users through a simple interface. So these are the three types of clouds that OpenNebula can build. So public cloud, it's a private cloud with a simple web interface that gives infrastructure resources in an elastic and this is an illusion, infinite manner. So the end user doesn't care about what's the capacity of the cloud he's using. He just launches virtual machines, and OpenNebula manages the infrastructure, so the resources are used in an optimized way. If you don't care about the public cloud interface, you can build a private cloud, which is just basically a cloud behind a firewall. So it's just made for internal consume. And the aim of having a cloud in your infrastructure, the ultimate goal is to improve operations and to improve the utilization of your hardware. Additionally, as said before, you can build a hybrid cloud, which basically supplements the capacity of your private cloud by outsourcing some of the virtual machines to a public cloud provider in case there's a peak demand and the infrastructure is saturated. So talking about the components that OpenNebula manages, as you see on top of OpenNebula, there's different interfaces and tools to help you interact with the cloud. There's a command line interface that is designed with the Unix philosophy, if you want to behind. So it's a simple command for simple tasks. And you also have a web interface. It's Sandstone that allows you a bit more of wizardry on top of OpenNebula. So it helps you use OpenNebula without having to go into a low level of detail like the command line interface needs. It also supports different APIs. There's the native XML RPC API, and also some Ruby bindings on top that are easier to use. We'll see afterwards a simple example of how you can write a Ruby script to help you manage your virtual machines. There's also the EC2 and OCCI public cloud interfaces. And there's other components like the OpenNebula apps that gives you the ability to do service management and also image catalog distribution across different OpenNebula instances. Other components that OpenNebula can manage are the network, so it can help you build VLANs across your virtual machines. It also gives you the ability to do firewalling rules on your virtual machines, and it supports multiple backends, so it's integrated with OpenVSwitch. It can use 802.Q1 protocols. There's lots of possibilities. This is one of the nicest things of OpenNebula is the modularity and the ability to integrate with different components, and it's also the most difficult thing about it because you have to tailor it to your needs, and at the beginning it could be a bit frustrating to make it work because there's a whole array of options that you have to cut down for your needs. But as soon as it's set up, then it's really easy to add new components and integrate with other software. In terms of storage, there's multiple backends supported with different protocols for image distribution. It also allows you to have multi-tenancy, and also the authorization module is pretty flexible, so you can integrate it with X509 certificates or LDAP servers or Active Directory, or you can even develop your own authorization module with a simple API to make OpenNebula interact with other services, like, for instance, Kerberos or something like that. It also manages permissions and roles, so it has a powerful access control list mechanism, so you can fine-grain give permissions to users to use just certain group of VMs or just a particular data store or just a couple of virtual networks. That's up to the cloud admin to figure out. And it also allows you to group hosts in different clusters with similar computer characteristics and also network layout. So you can ensure that one VM that needs a particular configuration ends up in the right hardware. Also, there's support for multiple hardware versions. So out of the box, you have support for Xen, KVM, and VMware ESX. Okay, some of the design principles behind OpenNebula. One of them is, of course, the openness. So it's an open architecture, open interfaces, tend to support as many standards as possible, if they make sense. Of course, it's open code. It's distributed in an Apache 2.0 license, which is pretty unrestrictive. It's also adaptable, so it has a modular architecture. That means that everything is plugin oriented. So the core daemon manages just abstractions of hosts and virtual machines, and it sends the command of, say, deploy this virtual machine to a small script that understands how to say that to KVM or Xen or VMware. And that goes for storage, networking, monitoring, and pretty much everything inside. It's plugin oriented. It's very light. The core is written in C++, and it's being optimized a lot, so the memory footprint is pretty low. It has lots of nice features for data center virtualization that we'll see in a while. So this kind of separates OpenNebula from the other cloud platforms that are more oriented to build Amazon-like clouds. So OpenNebula is just a tool for data center virtualization, more than a tool for making public clouds, although it can do them. It's interoperable, and the roadmap is not vendor-driven, so there's no vendor locking, or so we like to think. And it's enterprise-ready, meaning that it's being proven in massive, large-scale deployments, and we give single installing and update process and support for various platforms. For the upcoming 4.0 version, for those that you have used the software in the past, is a list of the new features. So Sandstone is being revamped and has this appearance now. The support for snapshotting, support for network cards hot plugging, also for saving a disk in a VM that is running. So this has to be handled with care, but there's the possibility to do so. Also, the ability to do vertical scaling, which is basically making a VM have more CPU and memory. Also, there's, and this is really nice, action scheduling. So you can say to OpenNebula, please shut down this VM next Saturday at 10 o'clock in the morning, and reboot it at 5 o'clock in the afternoon. There's also have been some key improvements in the command line interface, although they are not. They are just useful if you use it every day. You'll find out that there's some improvements. And there's new drivers for different technologies. The most important one maybe it's the Ceph drivers for storage. Okay, so now if it's okay with you, I would like to do a brief demo on the software. So this is this is the web interface of OpenNebula. So I'll just log in. So this is how it looks like. This is a dashboard. As you see, I have nothing in this cloud. Now it's OpenNebula. It's running in my laptop, and it's running using dummy drivers. So the operations are not really real. But still, I just wanted to show how it looks like, and especially the new interface, which I think is really nice. So basically, this is the dashboard. And this is the administrator view. So one admin will be the cloud administrator, and it has access to the system tab, which basically lets him see the different users. He can do stuff like change the group of a user, or delete the user, or create a new one, and so on. Has the access also to the same to the groups tab, which is, as I should say, it's a group of users, so nothing a lot of interesting. This is the ACLs, which these are the default ACLs in OpenNebula, which is basically saying that users, for instance, the first one, are allowed to create virtual machines and virtual networks and images and templates. So if you delete this ACL, then basically no one can do anything. And you can create specific ACLs for specific groups, for instance. Okay, then the administrator also has access to the, I'm going to create a user so we can log in as a user afterwards. So administrators also have access to the infrastructure tab, which the users won't have access to, or at least not to every single possibility here. So here you have the ability to create clusters. So basically, a cluster is a collection of hosts, as you see here, virtual networks, data stores. So data stores are basically a catalog of images. So you see here we have, by default, 3 data stores. One is the system data store, which is basically the runtime data store. So all the virtual machines that are running must be copied first to the system data store. So OpenNebula does that from other image data stores, like for instance the default. When you register an image, you register it to the default data store, and when you launch a virtual machine that uses this image, OpenNebula will copy it to the system data store and run it from there. There's new types of data store in 4.0, for instance, the files data store, which allows you to register any type of file, not just virtual machine images. And this is useful to be used in contextualization, which is the mechanism that allows you to pass information to your virtual machines. So basically, for OpenNebula, a virtual machine is just a black box. It doesn't open, so to speak, the virtual machine and put data inside. The only thing that it does is it passes information through a mechanism called contextualization that basically adds a read-only device to the virtual machine that can be read on the booting process and set up different things like the network information, for instance, user SSH keys and things like that. Okay, am I going too fast or no? Okay, perfect. Also, the system administrator will be able to create virtual networks. So virtual networks are used to communicate different virtual machines There's different possibilities here in terms of the network model. So you can use, this one is for dynamic VMware networking. This one is to use layer 2 filtration rules, also integration with OpenVSwitch. Well, so when you create a network, let's create one. Okay, let's make it. This will be the software bridge that needs to be present in the hosts. So this is basically a software bridge where the virtual machines will connect, and this bridge should be connected to a physical network interface so the machine can access the internet or access other virtual machines that are in another host. These are custom attributes that you can put here, things like, for instance, the gateway, and then this information will be passed on to the virtual machine that has to know how to treat it. So if you put here a gateway, then we provide also contextualization scripts for the virtual machines that will understand this data and set up the machine, but you can also write your own scripts that will just read information in the contextualization device and act upon it. So you can pass information here to set up services or the the password of the MySQL database and all that stuff. This is maybe interesting. There's always advanced mode, which basically this should work. But anyway, advanced mode is normally just a text area where you can paste your template. So if you ever used OpenNebula using the command line interface, you know that everything needs a template, which is just basically a text file describing the resources that you want to create. So Sandstone gives you the ability to have wizards and information that you need. It's all displayed here instead of having to go to the documentation and figure it out yourself. Okay, so let's create this network. All the resources have this information tab. So here you can do things like change the name of the network or set it to another cluster, manage the permissions. As you see, the permissions here are more or less like Unix permissions, the file system. So you have the ability to use this network will mean to create a virtual machine that uses IPs from this network. Manage this network will mean to add information to this network, like different configuration attributes or add some IP addresses, something like that. The administration permission would be the ability to delete the network, for instance, or change core values like the bridge, things like that. You can also change the ownership and the group of the network. And this is the inline editing for the general template mechanism that's available more or less in all OpenNebula resources. So you can set here specific information like I was going to do before in the creation. So you can say here, okay, the gateway for this network is something like that. And you have the ability to edit this inline. So this might seem not to be a big deal, but if you use the previous versions of OpenNebula, you're going to love this, I'm sure. Okay. Another aspect of the virtual network management is the list management. So, for instance, for OpenNebula, a list, it's a pair of an IP and a MAC address. So, because OpenNebula cannot force a virtual machine to have a particular IP, what we have is a convention. So what OpenNebula can do is to fix the MAC address of the network interface. So basically, what it's doing, the convention is, MAC addresses are is formed by 6 digits. So the first 2 are used always with a fixed prefix that is defined in the OpenNebula configuration file. And the last 4 digits are translated from hexadecimal to decimal, and that's the IP address that corresponds to this MAC. So a list in OpenNebula is a pair of IP and MAC address. So I can add to this empty network now a list, saying, okay, I want to use this IP for a virtual machine. As you see, it did generate. This is the default prefix for the MAC addresses, and this is just the translation of that IP in hexadecimal. You can erase it here. You can hold the IP to be used in future virtual machines, not that just the first one that asks for it. Anyway, this is the hosts tab. So basically, this allows you to manage your physical servers. So you can create hosts here. Let's create one. Okay. Let's set it to dummy drivers because I don't have virtualization capabilities in this Mac. Okay, so this is the host that I just created. These are the monitoring attributes. So the monitorization in OpenNebula is done through small probes that are run remotely through SSH in the hosts, and they pick information like, for instance, the host name, the free memory, things like that. You can change that dynamically, but in the next monitorization cycle, it will be overwritten unless you add a new parameter like, I don't know, color red. So what can you do with these tags? Well, you can say to your virtual machine, I want you to run just in hosts that have color red. And is this useful? Well, if you have the need for it, then it is very useful. If not, then no. Okay, that was pretty obvious. Another tab that I want to show is the Marketplace tab. So this basically what it does is connects to a service provided by C12E. So these are, well, C12E is the company behind OpenNebula. I'll talk a bit about it afterwards. So this is a collection of images that are prepared to be run with OpenNebula. So you can click on here, for instance, and import it to your local infrastructure. Okay. Basically, we'll download the image and put it in your data store of choice. Here, I guess I have the default one. Basically, we'll download the image, and so it'll be ready to be used by your end users. Okay, so let's switch the view and see what a normal user will see through Sandstone. So you have here the admin and the user view. Okay, so a user will basically see the data store and the virtual networks, and you will have access, of course, to the virtual resources. So you have the ability to create images like this one, and to manage its permissions. Also the ability to upload files and kernels. Kernels are useful for Shen deployments where you have to in virtualization, specify the kernel you want the virtual machine to be run with. This will be the views of the virtual machines of the user and the operations it can do with it. And these are the virtual machine templates. So let's create one to see how it looks like. So a user, when he wants to create a virtual machine, he will be presented with something like this. Have the ability to choose between the capacity, so a name, the storage. Just basically, you can set here different disks, and you can choose the image that you want, or you can use a volatile disk, which is a disk that will be made on the fly on the host where the virtual machine is going to run, and then it's going to be discarded, or you can choose to save it afterwards. You can add a list from a particular network. You have the booting options, also the ability to define a kernel and a RAM disk if you are running Shen. some input-output interfaces, like, for instance, if you want to access your virtual machine through VNC. And the context, which is information that you can pass to the to your virtual machine. I'm gonna remove this if it lets me. No? Okay, was luck. You can pass custom variables and also custom files to it. Yeah. Okay. Okay, so once I have my virtual machine template, I can choose to instantiate it. So once I instantiate it, it will become a virtual machine in the pending state. So now the scheduler is trying to find a place for this virtual machine, attending to its capacity. And so I think I didn't. Okay, I didn't show because I don't have permission. So if I go back to the admin view, a new tab here that is the scheduling tab. So here you can put some placement constraints on the virtual machine. So you can say, okay, I want this virtual machine to just run in this host or in this particular cluster. And you can choose the policy of this of the scheduler. So I want this virtual machine to act in a packing policy way. So it will go to the host with more virtual machines running. So you can consolidate your virtual machines in as few servers as possible and shut the other ones down or do some maintenance. There's different policies and there's lots of possibilities in the scheduler, which basically works as a matchmaking algorithm. You have two different requirements that you can set, the rank, which is here, and the placement requirements. So the requirements will be filtering out the hosts that are not suitable to run this virtual machine, and the rank will make a priority list between all the hosts that are suitable and pick the best choice. Okay. There's also been a great deal of name changing in the operation, so I think they are less confusing now than they were before. One nice thing that you can do with a virtual machine when it's running is, of course, change the capacity. You can attach new disks while the machine is running. You can attach new network interfaces while the machine is running as well. You can take snapshots of a particular disk. You have some information on the placement. And this is, I think, very nice. You can schedule actions like saying, for instance, shut down this machine tomorrow at 1 o'clock. So you add the action, and you can say, okay, but bring it back to life 1 hour later than that. Or something. Okay, that's, I think, an overview of the capabilities of OpenNebula using the Sandstone interface. Have any question about this, or you want to see something else, or understand how it works? Okay, I'll carry on then. Okay, as I said before, we are going to talk a bit about the key features of OpenNebula. One of them is the ability to handle different storage models. So you have multiple and heterogeneous backends that can be used simultaneously in the same deployment. So here you can see the OpenNebula frontend. It's managing different clusters. So these different clusters have different data stores, which are basically the image servers. So in this way, you can balance the storage servers, which is, in our experience, one of the most difficult parts at the time of designing a cloud. It's always the storage bottleneck. So this allows for different configurations. Like, for instance, the upper cluster can be run in a shared distributed file system model, whereas the one below can be run using some block device or fiber channel exporting of LUNs or things like that. So you can have your hardware distributed in clusters, like saying, here goes the fast VMs, or here goes the fast cloning VMs. Or there's lots of possibilities that allows you to design your cloud. So again, at the beginning will be a bit frustrating because there's a whole array of options, but I think that there's no one solution that fits all data centers. So having these lots of choices, it's at the end of the day good, but to start with, it's a bit difficult. Okay, another nice feature of OpenNebula is the ability to run the Ozone server, which is basically a component that lives on top of different instances of OpenNebula and manage them simultaneously. So you can have an aggregated view of all your OpenNebula instances. So say you have different data centers around the world, and you can manage them from a single point of entrance. This kind of features make OpenNebula at least a suitable candidate to think about from other proprietary solutions, like, for instance, VMware vCloud, which more or less tries to give the same functionality. For instance, the next one is the ability to create virtual data centers, which is basically the ability to reduce your resources to a subset and give them to the figure of a virtual data center administrator. So this guy will be able to manage just this subset as if he was the administrator of the whole cloud. So he will have the ability to create new users and the ability to give permissions to the users to use just certain networks and so on. And this model is really useful when you want to give multi-tenancy to your users. So you can have, for instance, if you are running a virtual cloud lab like Cisco is doing now using OpenNebula, they have the ability to create specific virtual laboratories to different groups of users using this kind of technology, which is really interesting. Okay, these other components that are shipped with OpenNebula, not at the moment, they are shipped separately, but with the same license. In the 4.2 version, they will be all packed together. So one of them is the app flow that allows you to manage services. So OpenNebula, out of the box, just manages single VMs. But with AppFlow, you can create roles, which is, for instance, if you have a web service, you can define the role of a template, of a front end, and you can define the role of, for instance, the master database, and you give the IDs of different VM templates. So this gives you the ability to manage the service as a single entity. So you can shut down all the virtual machines from a service. And in upcoming revisions, you'll be able to manage also the elasticity of the service, giving some rules or some key performance indicators. Okay, another of the OpenNebula apps is the app stage. That gives you the ability to use chef recipes to contextualize your virtual machine. So you can, using Chef Solo, you can tell OpenNebula, okay, I want you to create this virtual machine with a vanilla operating system. Please run this chef recipe so I can have my WordPress installed, for instance. The last OpenNebula app is the app market. As I showed you before, the marketplace tab that connects to a C12G service, well, this gives you the ability to create that in-house. So you have a catalog of images that can be shared between different OpenNebula instances across different data centers with different administrative domains and different storage models and so on. Yeah, another nice feature is the ability to create hybrid clouds. And you can create so in an automatic way. Well, not the creation of the cloud, but the use of the cloud. So you can teach the scheduler or well, set it up. So when there's no space left in the physical infrastructure, in the local infrastructure, it will start sending the virtual machines to Amazon. It won't do all the job. I mean, you need to have these virtual machines pre-uploaded in Amazon, but you can set them up so they connect through a VPN, and you can have the illusion of having your local cloud to be extended with the Amazon EC2 computing power. Okay, so a bit on the architecture of OpenNebula. So as you see, the big rectangle is the OpenNebula core, which is the C++ daemon that it's running all the time. And it communicates with the different components in the data center through drivers. So you have the monitoring driver that will check from time to time if the host is alive and the virtual machines are alive. You have the virtualization driver, which basically speaks with the hypervisor to do the the virtual machine lifecycle operations, like deploy it or take a snapshot of things like that. You have the storage drivers that basically will transfer the images from the data stores to the end hosts. You have the image drivers, which is the drivers that place the image inside the data store. You have the network drivers that speaks with the Open vSwitch, for instance, and creates VLANs for your virtual networks. And there's the authorization driver that basically, when a user request comes in, if it's enabled, it will talk with an Active Directory, for instance, and authenticate this user. Okay, so this is, we just talked about OpenNebula and the drivers that speak with the lower with of the cloud. On top of the core, you have an XML RPC API, which is used to communicate with the core and make requests about resource management. The scheduler uses this API to do the placement, so it will, from time to time, ask for the pending virtual machines and the state of the hosts, and will decide where which virtual machine goes. On top of this API, you have the OpenNebula Cloud API that comes with two bindings. There's more, but we just support these two, the Ruby and Java bindings. So you can create easily Ruby scripts or Java, not that easily, JavaScripts, well, not JavaScripts, but Java programs that automate certain tasks. And on top of that, you have the command line interface and the web interface, in this case, Sandstone, and the cloud service that gives you the OCCI and the Amazon EC2 interfaces. This is just a slide to convey the idea that it's really easy to, or well, it's doable to develop new drivers. So each of the operations, like for instance, create this virtual machine, is just a small script that receives a couple of parameters or a long base 64 blob with different bits of information, and creates just a single operation, like, okay, do a BRSH create of this virtual machine or stop this virtual machine. So if you see the code, it's really easy to hack and to create new ones. The communication is through ASCII pipes, so you can use basically any language. Most of the drivers are developed in shell script, but there's also small Ruby programs for more complex operations, and also some Python as well. And one of the nice bits is that different drivers can coexist in the same environment. So you can have at the same drivers for KVM and drivers for VMware, and they will have the same OpenNebula instance managing two different kind of clusters with different virtualization technology. So as it says there, they are really easy to adapt, to maintain as well, and it's really easy to create new ones. So this is an example of a script made in Ruby that uses the OpenNebula Cloud API. So this script will shut down all the virtual machines that I have access to. So the first thing would be to require the OpenNebula library, and then you have to create a client to talk with OpenNebula, which will basically will need the credentials and the endpoint where OpenNebula is running. This is the port, the default port for the XML RPC API. So once you have the client created, you can ask for the pool of virtual machines that I have access to. So this will give you a data structure with all your virtual machines. So then you can just loop through each other and do all the operations that OpenNebula is capable of. In this case, shutting down. And you can check if the machine has been shut down correctly or not. So this is a simple task that can be automated using a shell script. And well, if you are into programming, if you are and also sysadmin, I'm sure you will appreciate this kind of stuff. Okay, so some information on who is using OpenNebula. There's a lot of reference customers that ranges from supercomputing centers like Fermilab or the European Space Agency to banking entities like, for instance, the Santander, and also to big telcos like RIM, which now it's called BlackBerry. This is a really good reference use case because they use OpenNebula in all of the data centers around the world to give BlackBerry services. It's also used by companies as big as China Mobile. They have a kind of a clone like of the Amazon EC2 cloud, and it's run by OpenNebula as well. Well, some data on the kind of users that use OpenNebula. This is a survey, but I don't think you can read it very well. The information is in the web page if you are interested. Okay, so if you want to try out OpenNebula, I suggest that you start with one of the sandboxes, because installing it from scratch is not difficult, but the amount of work you have to do to configure it makes it advisable to use one of the pre-configured sandboxes. So if you want to try it out in just no time, you can download one of these sandboxes. There's one for VirtualBox if you want to try in the desktop. There's another one for VMware ESX, and also for KVM. If you go to opennebula.org, you'll see one of the tabs on the top is the tryout tab. You go there and you can download it and at least get a feeling of what OpenNebula does. If you want to get involved in the community, please do so. There's lots of things that people can do. The most important one, I think, is to use the software and give us feedback on what things are we doing wrong and what can we improve. There's lots of mechanisms to do so, like the development portal where you can file bugs, the mailing list that is used to give support by the community. You can also help us translate OpenNebula to your favorite language. lots of possibilities here. The community is quite active. We have lots of contributors. The Sandstone has been translated to 17 languages, and there's companies contributing to the ecosystem. We also have an IRC channel where developers used to hang around in case someone has any problem. Just write it there and we'll answer it if we are available. Just a bit of data on C12G. So C12G is the company behind the OpenNebula project. It has a lot of expertise on cloud deployments. We've been working almost 6 years in the field. We have a service and partner program. So we can help our partners to create customized cloud services and products. We work on a subscription model, so no upfront investment is required. Just a small fee to support your cloud deployment is needed. And the support is straight from the developers of the software. One of the important bits of having this in mind is that the software is mature. I mean, it's proven with massive deployments, so at least I think it deserves to give it a try. And this is just thank you slide for bringing me here, NETWAYS. I just want to announce that they are our first premium partner, so I think we'll make a good team to offer services and consulting on OpenNebula-based clouds. So thanks for having me today. And that'll be it. Do you have any questions? It's not time.
So, any questions, anyone?
I was always wondering about this virtual kind of solutions, is how you put the upper limit, for instance, on the cluster of machines. I'm talking about real cluster, the HPC, some solution with the thousands of compute nodes connected. And for instance, you want to make the share, and one customer would be able to use 100 nodes connected to the same storage system, another 100 nodes. And then how you put the limits on how those customers will use the InfiniBand, for instance, and then the storage in terms of IOPS.
Mm-hmm. So I guess you were talking about the quotas that the users have.
It's not really the quotas. This is kind of upper limits. I mean, when you put the quota on the storage, you just put the up to some storage capacity. But mm-hmm. Here I'm talking about IOPS, so that one customer can generate real lots of traffic and get unstuck the whole system, while the other customers will be just waiting for the response from that storage system.
So I see. So what you mean is, how do we make sure that a customer is not clogging the system by making 1,000 requests, for instance, to create VMs?
Specific to the network and the storage.
Yeah. So we don't have a specific solution for that, but we work with quotas. So you can, in a way, you can design your cloud so. If one user is clogging up one certain cluster, the other users will use another one. If this user clogs one cluster, it is true that the other users that are using virtual machine from that cluster will suffer from that. Network-wise, there's not a clear solution. In terms of the computing resources, yes, because if you don't do overcommitting, for instance, virtual machines that are running in one host cannot use more than the CPU that is allowed to use. But it's true that network-wise, you can get into trouble if one user starts 1,000 VMs in the same cluster at the same time. That's something that can be worked upon, and it's not really there.
Any further questions? Okay, so, well then, Thank you, Tino, for the presentation of OpenNebula.
Thank you for having me.